In this video, we're going to be using a feature of Excel called Solver to determine the optimum product mix for a company. We're going to be using problem 459. It's on pages 149 to 150. The spreadsheet we have here is a replica of the spreadsheet that is given on page 150. Notice I have left out 3 cells. In order for Solver to work correctly, these 3 cells have to be formulas. So let's take a look at building those formulas. The first one we're going to determine is the profit based on the planned production that is given in the problem. To determine the profit, we need to come up with a formula, and we're going to use the contribution margin per unit for each of the products times the quantity produced less the fixed cost, and that will give us our planned profit. So we begin by building our Excel formula. We're going to first do the standard. The contribution margin is $1.50. We plan on making 90,000. We'll then do the same for our custom. $2 contribution margin, 50,000 planned units, and then we subtract out our total fixed cost of 113, and that gives us the profit amount that we see over on page 150 in cell C23. But now this is a formula. If you just typed in 122, that would not work. All right, so let's take a look now at building the formulas for the hours used. The total hours used in the grinder is going to be the number of hours per unit for each of our products times the quantity of units produced. So again, we'll build a formula for that. We'll say we're going to build 90,000 standards. They require 0.2 hours each. And we're going to build 50,000 units of the custom, and they require 0.3 hours each, which means we are scheduled or planning to use 33 hours for the grinding machine. We're going to use a similar formula for the finishing. Again, we're going to produce 90,000 units. It takes 0.1 units to do the standard. The custom, we're going to build 50,000 units. It takes 4/10 of an hour to build them, and we're going to use 29,000 hours in total. And again, you see those are the same numbers that you see on page 150. Now that we have our formulas built, we can go ahead and use our solver. Solver is located over on the data tab, so we'll click on that. If you do not see solver on your version of Excel that you're using, that means it has to be added in. In this version of Excel from Microsoft Office 2007, we're going to use this little Office button. If you're using a later version, you'll use the tab to the left of the home page. So we click on that. We're going to locate the Excel option. Again, here it's in the bottom right hand corner of the box. In the later version of Excel, it's located on the left side of the pop-up box that comes up. So you would hit Excel options. We are looking for the add-ins. Since I have Solver added in already, it's showing here as active. If you see Solver in the inactive, you need to go down to the Go box here. Click on the Go box. This little pop-up box will come up, and you would click on the Solver add-in, hit OK, and when you come back to the Data tab, you should see Solver there. So we're going to click on Solver, and the objective of this worksheet is to determine the maximum profit. So we're going to set the target cell as our profit. and we want to set that to the max. We're going to achieve this optimum profit by changing two quantities. We're going to change the number of units of standard, so we'll click on cell C21. We also are going to change the number of customs, so we hold down the control key, click on that cell. Now this gives us the cells that we're going to change. However, we are limited. We have certain requirements to ensure that impossible amounts do not pop up in the quantities produced. So we're going to add some constraints. And the first thing we want to do is say that these amounts produced cannot be negative numbers. So we're going to click on the standard productions, C21, and we're going to say that has to be greater than or equal to 0. That'll prevent us from coming up with a negative amount for units produced. We're going to click Add to put in another constraint because we want to do the same thing for the custom. Again, that has to be greater than or equal to 0. We're not finished. We don't want to produce more than we can sell. So we want to say that the units of standard that are produced has to be less than or equal to the demand for that product. So this will ensure that the quantity produced cannot exceed 100,000. Okay, and again, we'll add that because we want to do the exact same thing with the custom. All right, we'll hit add because, again, we're not done yet. We have to look at our production limitations. The number of hours we have on the grinder cannot exceed the available grinder hours, and that varies based on the units produced. So we're going to tell it that the number of grinder hours used has to be less than or equal to the number of hours that are available. And we have to do the same thing for the finishing. And that is the end of our constraints. So we'll click OK. So we've set our profit cell to be our target. It's set to the max. It's going to change the quantity produced for the standard and customs in a way that will maximize our profits with the following limitations. The quantity produced cannot be greater than the demand. The quantity produced cannot be 0. The machine hours used cannot exceed the maximum amounts. And now we'll go ahead and hit solve. And just like that, Excel has changed the quantity produced and shows us what the maximum profit is. So we can say, go ahead, we want to keep that answer. And that's how we would use Excel to determine the optimum product mix.